There, it's Workbench with Workbench Quagmire, back for day 37 of our Free Code Camp Python certification in 100-ish days. Today we're going to carry on with the theory sections on classes and objects. We're going to go through a couple of these, and then we'll start into one of our first labs or workshops or whatever it's called for this section. So let's just jump right in. What are special methods and what are they used for? Special methods in Python, also known as magic methods or dunder methods, are special Python methods that start and end with double underscores. The word dunder itself comes from the double underscore, D for double, under for underscores. You've probably used special methods already without knowing it. Every time you write something like 3 plus 4, Python quietly runs 3.add 4 under the hood. That's a special method in action. So while you can call special methods directly, you rarely do. Something like 3 plus 4 is much clearer and easier to read than calling 3.add 4 yourself. Apart from add and init, apart from add, init is another special method you'll see and use the most. It is a class initializer. There are also others like length and string. Think of special methods as the directors of the activities between a person programming and the Python language interpreter itself. Remember, you don't need to call special methods directly. Instead, Python automatically calls them when certain actions happen. These operations include arithmetic operations like addition, subtraction, multiplication, division, and others. In addition, add is called, sub is for subtraction, moles for multiplication, and true div for division. String operations like concatenation, repetition, formatting, and conversion to text. Add is called for concatenation, mul is for repetition, format is for formatting. String and repr are for text conversion, and so on. Comparison operations like equality, less than, greater than, and others. So we have equals is called for equality check, LT for less than, and GT for greater than, and so on. Iteration operations like making an object iterable and advancing through items. So iter is called to return an iterator, and next to fetch the next item. Normally, Python data types like strings and numbers already know how to add things, do concatenations, compare for equality, be used in loops, and other. But when you create your own class, Python won't know how to handle this things automatically. This is where special methods come in. They let you customize Python's built-in behaviors. Let's say you want to get the number of pages in a book objects created with the class below and compare them and get a readable string of the objects. Here's what happens without special methods. So we have a book class, we have an init method that gets our title and the number of pages, and then we create two instances or objects, book 1, book 2, different titles and the same page length. If we print the length of book 1, we get a type error. It says book has no length. And if we print the string book 1, we get book object. And then if we try to compare the two books, we get false even though they have the same number of pages. So, for example, length book 1 failed because Python doesn't know how to get the length of your book without length. String book prints something like, this main book object at, memory location, because the default representation when you don't use string, book 1 equals book 2, results in false because Python is just checking if both objects are in the same memory and not by content. Here's how you can define length, string, and equals or equality special methods to make working with objects created from book class easier. So we have our same book class with the same initializer. Then we define length and return pages. And then we define string and we return a string that we create that has the book title and the number of pages. Then equality returns self pages equals other pages. And so we have to give that, obviously, this object and another object, another book object, or another object created from book class. And we create book 1 and book 2, the same as we did before. Then now we get, when we print length of book 1 and length of book 2, we get 420. If we print the strings for book 1 and book 2, we get the titles. And then if we compare book 1 and book 2, we get true now because it's comparing the number of pages. Another example is a shopping cart where you do the following: add items, remove items, get number of items, check what items are in the cart, check if a specific item is in the cart, and return or display an item at a specific index in the cart. While you might have a method that adds items to the cart and removes certain items from the cart, you can create special methods for all the other functionality. So length will give you the number of items in the cart. Iter will loop through the items in the cart. Contains will check if a specific item is in the cart, and get item to return or display the item at a specific index. So here's an example of our cart class. Our initializer is just a blank or an empty list. And then we have add for adding to the list, obviously items.append item, and then remove takes self item, and if item is in items, it removes the item. Otherwise, it's not in the cart. So list items basically returns the list of items. Length gives the length of the list. Get item takes the index we want to get, and then we look in that index location for an item. Contains, we take the item and return if a Boolean, if the item is in the list, true or false. And the iter, so it'll just iterate over the items. So here's how you can use them. Cart equals cart, cart add laptop, wireless mouse, ergo keyboard, monitor. Then for item in cart, print item. This end with a space basically takes what it would normally be for each item. At the end of this print, there's a unseen \n or new line. And this basically substitutes a space. So instead of getting each item on a line, it puts this space in between each item here that we see in the sample output. Print length of cart is 4. So we put 4 things in it. Cart 3 tells us there's a monitor there. Print monitor in cart. Yeah, there is a monitor in cart. There is no banana in cart, so we get false. Cart remove ergo keyboard, and then print cart list items. List all of our, actually outputs the list of items. And then cart remove banana, and then banana is not in the cart. So there's a few ways you can use special methods in Python and real world. So let's take our quiz. Which of these is a special method called during an addition operation? Plus, no. Sum, no. It was add. Concat, nope. How was the word dunder derived? It comes from a dynamic under the hood operation. No. From shortening double underscore. That's true. So our second choice. Let's see what else. From the creators of Python's nickname. That's funny because I don't know what Guido von Rossum's nickname is. It's probably not dunder. From data under in the reference to the hidden methods. Nope. Choice 2. Which of the special methods is called when you use the greater than comparator? More? No. Compare? No. Greater? That seems like it might be right, but we remember it's GT for greater than, and less than's LT. So let's see if we did okay. There we go. Last theory section for classes and objects. How to handle objects attributes dynamically. In a previous lesson, you learned about attributes being the variables that belong to an object. That means they hold the data that describes the state or behavior of the object. For example, a car would normally have a brand and a model. The brand and model could make attributes for a car. So here we have our car class with attributes for brand and model. So my car, we create a Lamborghini Gallardo. I think that's how it's pronounced. And we can print car brand and car model, and we get those. But sometimes you might not know which attributes you'll need until your program is running. Imagine you're writing a script that receives attribute name from a user or configuration file. Those are not attributes you can hard code ahead of time. That's where handling attributes dynamically comes in. This way you can access, modify, check, or even delete attributes using their name as a variable and not as fixed name in your code. This gives your program the flexibility to respond to different data or user input on the fly. So Python gives you 4 handy built-in functions to dynamically work with object attributes. They are get attribute, set attribute, has attribute, and delete attribute. So getter, setter, has, and delete. They let you access, create, check, or remove attributes using variable names. Let's take a look at each one in action. So getter makes it possible to read an attribute from an object when you don't know its name until runtime. If the attribute doesn't exist, it raises an attribute error, and unless you provide a default value. To use it, you pass in the object, attribute name, and optional default value. So there's this method. We have the object, attribute name, and default value. Here's an example for a person. We have a name and an age. We create a person named John Doe who's 30. Print get attribute person name, John Doe, get person age 30, and get person city, Milano. And since there is no city attribute, we default to the default Milano. In the above example, Milano is the default value because city doesn't exist in the person class. As we said earlier, the real power of getter is apparent when the attribute name comes from a variable, such as from user input or some file. In this case, you can't use the regular object attribute name syntax because attribute name is not fixed. So class person, name age, create a person again, get attribute input, or the attribute name is input, enter the attribute you want to see, and then we print get attribute person attribute name, and then the default is attribute not found. In this case, if the user types in name, they see John Doe. If they type in age, they see 30. And if they type in something that doesn't exist, like email, they'll see attribute was not found or attribute not found. This is exactly where dynamic attribute handling shines. It lets your code respond to input and data it hasn't seen before. In addition, you might want to look through all the attributes an object has, not just the ones you already know. The built-in dir function lets you do that. And if you watch some of these videos, you see me do that a couple of times because I learned that years ago. And that's how sometimes I'm like, what can I do with this thing? Or what does this thing contain? It returns a list of all the attribute names on the object. Here's how to use it. So we have our person. We create a person. And for attribute in dir person, ignore the dunder methods because the dir will return the dunder methods and other methods as well, or string. And then if attribute starts with, underscore, not or is not callable. So then the value equals the attribute, the person. We give it the object and the attribute, and then we print the attribute and the value of that attribute. So here's an example: output, age, name, John Doe. Set attribute functions lets you create new attributes or update an existing one dynamically. The syntax looks like this. So we pick the object, what attribute we want to create or update, and what the value is going to be. Here's an example of that sets a config attributes based on data from some config or environmental variable file. So in this case, the interesting thing here I thought was we just create an empty class. This class has no attributes. It doesn't have any methods. It's just an empty class. So then we have this library or dictionary. We have this dictionary here, library, dictionary, and it has this keys and values. And then we create a configuration object from the configuration class, which is just an empty object. There's nothing in there. But then we go through and say for attr name and attr value in the settings data items, right? So this returns both the key and value. Set the configuration variable or config object. So we've got our object, our attribute name, and our attribute value we want to add to the object. So then when we're done, we can print the server URL or the timeout. And we have those now when we started with an empty object. There's also has attribute before you do something like with an attribute or delete it. It's good practice to check if it exists. That's what has attribute lets you do. It checks if an attribute exists and returns true or false based on the result. Here's a basic syntax, has attribute, object, attribute name. And here's an example that dynamically checks for existence of an attribute in a product class instance. So here we have our product class and our attributes are name and price. And we have product A, which is a t-shirt for $25, and required attributes are name, price, and inventory ID. Well, we didn't define inventory ID. So for attribute in required attributes, if not, has attributes product, the object, and the attribute. So if this is true, it will be flipped to false. So we would not print this, but if this is false, it flips it to true, so we do run it. That's confusing to me. Otherwise, we just print the attribute. So we print the attribute and that it's there, or what it is, because we're getting it. So then you see the output down here, the name, t-shirt, price 25, and then because we don't have, what was it, inventory ID, products missing attribute, inventory ID. The error output occurs because inventory ID is missing from the product class and its instance. Lastly, delete attribute lets you remove an attribute dynamically. So it just takes the object and the attribute name. For example, imagine an object is fully processed and then you decide to clean up any sensitive or temporary attributes that might exist before saving the final version. After that, you can use dir to look up through the remaining attributes. So we have a user session and we have a user ID, authentication token, and temp counter. We create a session with the user session class, and with user IDs 101, we have this authentication token, and then a list of attributes to remove dynamically before saving. We were going to get rid of the token and the temporary counter. And for the attribute and attributes to clean, we go through and look at our object. Does it have the attribute? If it does, delete the attribute, remove the attribute, whatever it is. So then we print final attributes remaining, and then we loop through again and basically print these out. So we remove the authentication token and temp counter, and then the thing that we have left is the user ID. And that's how you can handle attributes dynamically. All right, let's go for our quiz. What does getter function or the get attribute function in Python allow you to do? Read an attribute from an object when its name is unknown at runtime. That's true. Delete an attribute? Nope. Set a new attribute as an object? Nope. Set a new attribute on an object? Nope. That would be set. This would be delete. Check if an attribute exists. That would be has attribute. So choice 1. Why would you want to handle object attributes dynamically in Python? To convert attributes to a list automatically? No. To make attributes read-only? No. To reduce the number of class attributes created? Not really. To work with attributes whose names aren't known until runtime? True. Choice 4. And what is the correct syntax for checking if an object has a specific attribute in Python? So check attribute, no, it's has attribute. Set, no, get. So this has to be the correct choice 2. And there we go. That completes our theory sections on classes and objects. Next time we'll do this build a musical instrument inventory workshop. I think it's pretty short. 13 steps. So we'll go through that. And then we have a lab after that. So this will probably be tomorrow, and this hopefully will be the day after that, maybe 2 days. It depends on how big of a lab it is. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you tomorrow.